Hello students, this is Dr. Sourav sir's class and I am going to solve a problem which came or appear on the UPSC 2024 Mathematics Optional Paper Part 1. Okay, what the question says? The question says that let us consider a linear operator T on R3 over R defined by Txyz equals to 2x, 4x minus y, 2x plus 3y minus z. Now we have to find that if T is invertible or not. If yes, then we have to justify our answer and find the T inverse. Okay. So the given linear operator is Txyz equals to 2x, comma 4x minus y, and the last entry is 2x plus 3y minus z. Okay. So let's express T in matrix form. For any vector Vxyz, it will be formed that Tx, sorry, so this will be firstly 2 0 0, there will occur 4 minus 1 0, then 2 3 minus 1 of xyz. Okay, thus the matrix representation of T is this. The matrix representation of T is this. Now we have to check if T is invertible or not. So let us take the determinant of T. If it is 0, then it's singular, and singular matrix is non-invertible. So we have to see that if the determinant of T is non-zero or not. Okay, determinant of T will be calculated as 2 into the minor will be minus 1 0 3, then also minus 1, so it will be, and then 0, then there occurs 0, so this will be 0, and there is 0, so this will also be 0, so minus 0 and plus 0. So our answer is 2 into 1 equals to 2, which is not equals to 0. So the matrix is non-singular, and non-singular matrix is invertible, so T is invertible. Okay, the first part is done. T is invertible, and this is yes. Okay, this is yes. Now we have to find the T inverse. So how can we find T inverse? We know a fact that T inverse equals to adjoint of A, sorry, okay. Let us take the matrix representation of T is A. Okay, so this is A. Now we know a fact that A inverse equals to adjoint of A by determinant of A. We all know that. So now I am using it in our question. So we have to find the cofactors first, the cofactor matrix of A. So the cofactor of A11 equals to 2 dot dot, it will be minus 1 0 3 minus 1, and then it is 1. Now cofactor of A12, it will be, here is 0 and there will be 4, 0, 2 minus 1. And 4 into minus 1 will be minus 4, and minus 0 into 2 will be 0. So there is minus 4. Now we have to find the cofactor matrix of A13, as A13 is 0 and there occur 4 minus 1, 2 and 3. So 12 plus 2, it will be 14, and for A14 it is, we lift the paper. Okay, A14 equals to, sorry, A14 no, it will be A21, then it's 4 and 0, 0, 3 minus 1. So 0 into 0, 0 into minus 1 will be 0, and 0 into 3 will be 0. So it will be 0. And now we are going to find for A22. The entry of A22 is minus 1, and this will be 2, 0, 2 minus 1. And 2 into minus 1 will be minus 2. So this is minus 2 now. For A23, which is 0, then 2, 0, 2, 3, which will be 2 into 3 is 6, and minus 0 will be 0, so it is 6. And for A31, this is A, for A31 entry is 2, it will be 0, 0 minus 1, 0, which is 0. A32, it will be 3, and this is 2, 0, 4, 0, this is also 0. And for A33, the entry is minus 1, and this matrix is, sorry, 2, 0, 4 minus 1. So it will be equals to minus 2. So our cofactor matrix of A will be cofactor of A is equals to 1 minus 4, 14, 0 minus 2, 6, and it will be 0, 0 minus 2. Okay. Now we have to find the adjugate of A. So what will be the adjugate of A? The adjugate of A will be this: A, 0, 0, minus 4, minus 2, 0. Just transpose of that only. Okay. Now we have to compute A inverse. So our A inverse will be adjoint of A by the determinant of A, which is 2. So our entries will be half, 0, 0, minus 2, minus 1, 0, 7, 3, minus 1. This is the answer of this question. Hope we understood and solved this question. Okay, thank you.